Hello everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology. So today we are going to discuss about image degradation and restoration model from Unit 3. It is about image restoration. Before going to the topic, let us have a small recap about the previous unit, that is image enhancement. So image enhancement is a technique which is used to improve the images. That is, it is mainly used to improve contrast and brightness. And in unit 2 we have studied some noises, that is Rayleigh noise, uniform noise, salt and pepper noise, exponential noise, and how they affect the images. Now let us move on to the topic. So first, why we need this image restoration? So the images, that is image restoration, mainly focuses on recovering original images degraded by blur and noise. So most, that is, this is, for example, this is the original noise. This is the original uh, that is, this is the original picture, and this is optical blur, this is motion blur, this is spatial quantization, that is discrete pixels, and this is affected by the intensity noise. So that is, the noise may arise from sensors, transmission errors, or environmental conditions. So it is mainly, that is image restoration technique is mainly used to recover the image from noise, image blur, and resolution loss, quality degradation, and atmospheric distortion. These are the empathy of using image restoration. And the causes of image degradation is atmospheric turbulence, misfocus of a lens, relative motion between camera and the object, which causes motion blur. So mainly it is used to improve image quality for application in medical imaging, remote sensing, and communication systems. And the principal goal of restoration technique is to improve the quality of image. So any image may corrupted by noise, or may corrupted by that is it can be degraded by blur and distortion artifacts. So the image restoration is defined as the process of reconstruction or recovering an image which is in the degraded or restored state, that is from the blur and from the noise. So the restoration is used to recover an image that has been degraded by using appropriate prior knowledge of the degradation phenomenon. And before that, we should know what is the difference between image enhancement and image restoration. So the image enhancement is mainly used to improve contrast and image, but the image restoration can be used to recover the image from the blur and degradation function. So the modeling of degradation process is not required for the image enhancement, but the modeling of the degradation it should be known for the image restoration. And appropriate, that is prior knowledge of the degradation function is not required for the image enhancement, that is to improve contrast and brightness, it should not require. But for the image restoration, a prior knowledge about the degradation, appropriate knowledge about the degradation function and noise function should be known. uh, these are the differences between image enhancement and image restoration. So this is the function, that is, this is the defined part of the image restoration. Here the f of x comma y is the original image. So it is degraded, some camera misfocus, or some environmental condition, that is it is defined as h, that is degraded function can be defined in h. And this is the noise added in the, that is eta of n comma n of eta of x comma y, this is noise, and degraded function, and noise is added, and the resultant equation is g of x comma y. So g of x comma y is the degraded image, and it is applied to the restoration filter, and after that we are getting f dash of x comma y, it is the restored image. Here g of xy is a degraded image, and f dash of x comma is the restored image, and n of that is eta of x comma y is the additive noise. And there are you already know that there are two domains, spatial domain and frequency domain. If h, that is degradation function, is linear and position invariant, then the degraded image in the spatial domain is small g of x comma y is equal to f of x comma y into h of x comma y plus eta of x comma y. And the same equation can be written in frequency domain as capital G of u comma v, here x comma y, and here u comma v, capital X of u comma v into f of u comma v plus n of u comma v. So the terms in capital letters are the for representing the Fourier transforms. Because we can use two types of restoration techniques. One is frequency domain approaches, and another one is algebraic approach. So in frequency domain technique, it is relatively less computational complexity. So the computational complexity is very less, whereas the algebraic approaches involves manipulation of large equations and large systems of simultaneous equations. And in the ideate part, we have some restoration approaches. We have some of restoration approaches, that is inverse filtering, Wiener filtering, constrained least squares, and unconstrained least squares. So the difference between constrained restoration and unconstrained restoration is, the unconstrained restoration is a method of image restoration in which the solution is obtained without applying any additional conditions or constraints on the restored image. Example, inverse filtering. And constrained restoration is a method of image restoration in which the additional constraints like smoothness and minimum error are applied to obtain a stable and better solution. The example is Wiener filter. So the inverse filter and Wiener filters are the main filters used for the restoration. So in the inverse filter, we the degraded image can be restored, and by using Wiener filter, the noise and blur function, but that is both the function can be restored. So these are the some images for your understanding. So using restoration, we can reduce peak signal to noise ratio and mean square error and structural similarity index. These are the some values of MSE, that is mean square error 255, here also 255, but the SSIM is here 8.653, here 0.892. This is denoised image, this is also the denoised image. And these are the some assessment questions. The components of image restoration, that is g of x comma y is equal to h of x comma y. What are the components, and difference between the inverse filtering and Wiener filtering? These are some questions. So hope this video will help you to understand what is image degradation and image restoration. Thank you.